wire can't move. This connection right here has to be very tight, because if there's a little bit of air, there could be arcing created. And that arc allows a lot of current to flow. Instead of only 0.89 amps flowing through here, that might go up to 6-7 amps, and it could burn down this light. And if it's right here in the plastic box, what do you think is gonna happen to the plastic box? It's gonna melt. And if it melts and it starts burning up the wood, it's gonna create a fire. And that's why a lot of the fires that occur are because of loose connections. The installers do not take their time to tighten all of the screws, and all of the screws that you connect to your devices, for example here, they have to be looking in the right direction, and all of these have to be nice and tight. This is something that I'm gonna be checking. If your box is loose, that's not gonna be such a big deal as if your connections right here are loose, your splices are loose. This is gonna look very unprofessional, but somebody can go ahead and just tighten it really quick. But when it's regarding your installation, nobody's gonna really look into it. You have to be responsible for everything that you're connecting as an electrician, okay? Now here, we have a simple switch, and we have 3 lights. That's what we have right here. Then we have, we could have a switch turning on receptacles as well. On this side, we actually have a kitchen that was wired. We have countertop kitchen receptacles protected with GFCIs. We have a light right here. We have a GFCI over there. And we have 2 GFCIs here for 2 appliances. And we have 2 dedicated circuits for another appliance. The most circuits that we're gonna have are gonna be in the kitchen, because we have a lot of appliances that work separately, that are fixed in place, that per the code, they need a dedicated circuit. So I want you guys to take a little bit of time and observe. You can go ahead and take off wire nuts and check the projects that I have here for my students. I'm very thorough when I'm checking, so go ahead and get familiar, so that when I'm talking in the class, you're not oblivious of what I'm telling you guys. So go ahead and observe the installation. You can pull it out and you can look at the devices. Those are kitchen countertops, yes. Kitchen countertop receptacles. ¿Cómo está? ¿Por fin apareció? 12, 2, and 12, 3. So our 14 has a black conductor. I'm gonna use yellow. This is gonna be our neutral. That's gonna be the white conductor. All of them will have a white conductor. All of them will have a bare conductor. I'm gonna go ahead and use green just as the bare. This wire is for safety. It's connected to all of the green screws on our electrical system, and only the 14-3 will have that extra wire, and that 12-3 will have that extra wire, so that we can use it as maybe another circuit, or we can use it for a 3-way system, like when we want to turn on and off our lights in 2 different places, or when we want to turn on our lights on and off in 3 different places. Then sometimes we'll need that extra wire, and that's why we have 14-3. Now Romex does make 14-4, they make 14-5, they make 14-6. They can make as many conductors as you want, but those are specialty wires. If you go to Home Depot and Lowe's, you'll find 14-2 and 14-3. If you want a 14-4, now you have to call the manufacturer and tell them, I need a 14-4, and they'll make it for you, because the manufacturers are like that. They have more, but of course that's gonna cost a lot more money. Okay, so these are, this is for, Romex is for residential. Is for residential installation. Romex is for residential installations. Now, if my customer wants everything to be wired with a raceway, I could do it. Anything that is commercial or industrial can be used in residential. The only thing that is much more pricier, it costs a lot more money, but there are some customers that will pay more because they don't want Romex. They want everything to be piped up. They want everything to be another material which is called MC, that instead of having this plastic jacket, they have an aluminum jacket, but that's way more expensive than Romex, right? So this is affordable for homeowners to be able to wire their house with Romex, and this is what is widely used in residential installations. Does anybody have any questions on what you guys saw in the lab? Most of the receptacles in a house have to be tamper-proof so that children can't stick anything in there and get electrocuted, right? So, but the height of a receptacle, that's gonna be the architect or the electrician. Best practice is if you go into a house and you're adding something to the house, let's say you're adding a switch, go and measure the switches of the house and then put that at the same height, because it's gonna look uniform with everything else that already exists, okay? So the code is not a design manual. The code is not to tell you what height to put the receptacles. They'll talk about how to connect and how to avoid fires and how to avoid shocks and electrocutions, okay? So to answer your question, we have a certain height that we put certain devices, and you guys are gonna have to follow my designs and my instructions. But maybe you go and you work for a GC and you tell them, oh, the receptacles have to go at 12, and he's gonna tell you, where in the code does it say that? You can't find that in the code. It's not in the code. It's just whatever the person that's in charge of the project, what they decide. Okay? So, any other questions?
Oh, I noticed on the breaker, there was a 30 amp, I think.
Mm-hmm.
What is that used for?
30 amp would be used for a 30 amp wire. 40 amp breaker would be used for a 40 amp wire. A 50 amp breaker would be used for a 15 amp wire. So for example, a 15 amp breaker is used for a 14 gauge wire. A 20 amp breaker is used for a 12 gauge wire. A 30 amp breaker is used for a 10 gauge wire. So depending on the size of the wire, either less amperage should flow through it or more amperage should flow through it. So the breaker has more resistance for the amperage. So for a main breaker in a house, you might have a 200 amp breaker. So the lugs there are gonna be really wide because you're gonna put in a very large conductor there, right? So that's what it means. Those numbers are the amp capacity of the circuit breaker. So you would say that if it exceeds a safe amperage, then it's gonna trip, okay? Any other questions? No? Now, did you guys notice how everybody was running their wires differently? Some of them looked nicer than others. I always tell the guys, make sure that your work looks intentional. Don't just run your wires. Make sure that everything looks intentional. Like you took your time, you planned it out, you went in, you didn't leave your wires too short, you didn't leave them too long. And this is what I do with you guys in lab. So it's gonna be about 4 to 5 weeks that you guys are gonna be in lab, but it's gonna be about 9 weeks that you guys are gonna be in class, just receiving theory, just reading the code book, just getting tested constantly, and that's where I lose a lot of students. I tell them, just bear with me, be strong. I tell them, be strong, because it's hard. You guys are tired from working in the morning, and then you come here and you have to read, you have to do math, then you have to get tested constantly. But don't drop out, because at the end, you guys are gonna be doing lab. Everything that we've been talking about, everything that I've been drawing on the board, you guys are gonna be able to put them up and actually wire them up. So I feel really sad when some of the students are like, I can't keep up. Like, I can't do it. I was like, you can do it. You just have to push yourself, and you just have to make sure that you're making good use of your time. So that's why I'm telling you guys this, so that you can start mentally preparing, right? If a person is mentally prepared for what they're gonna do, it's gonna be very hard for you to get discouraged. But if you come in with the mentality of, I'm just gonna do the bare minimum, I don't think you're gonna make it in my class. Because we want, I don't like to weed out people. I don't like to weed out people. But I'm going to shake you because I know that you can do better, right? I'm going to expect more from you because all of us have a lot of potential. We just sometimes don't know it. Nobody has ever expected anything from us sometimes, right? Nobody has ever told us that we can do things better, and some of us are not even used to criticism. I had an interview yesterday with one of my students because he started with me an intro like you guys, and he's in Mod 1 right now, and he's been one of the students that has been very teachable. He follows instructions, and every time that I give him some criticism, he'll go ahead and he'll do what I tell him. So I told the students, go ahead and get your training card. He was the first one who applied. Go ahead and start looking into the unions. He went ahead and he started putting out applications. Usually the unions take about 2 years. He got an answer in 3 months. So he's getting an interview next week, and we were doing mock interviews, and I was going over his resume. And I remember he was telling me, like, I can't believe how far I've come because nobody has ever believed in me. Everybody, a lot of the people that I've grown up with has never expected anything from me. But when I came into this class and you started like pushing me, and you started telling me that you have to do this, you gotta do that, you gotta do this, I felt like something was expected from me. And he's one of my best students, and I'm pretty sure he's gonna get that position in Local 11, and he's gonna start working in Hollywood doing motion picture installations. And those are apprenticeships that don't open up pretty easily, but he got a call really fast, and I think he's gonna do great, but because he's been teachable, he's been moldable. He's very young, he's 22 years old, and I think that it doesn't matter what age we're in. If you set your mind on something, you can do it. And I'm gonna push you guys in the lab, and I'm gonna push you guys in class, because I know that some of us, we work better under pressure, right? I work better under pressure. When they loosen the reins on me, I get a little bit lazy. But when somebody is putting fire under my feet, I work better. So some of us, we need to have a little bit of pressure to be able to shine like gold. Gold has to go through fire, right? To be able to look as beautiful as they look when you put it on your finger. But you have to be resistant to all of this, guys. So getting to that point where you guys are going to be over there into that lab is a long way from right now, right? It's a long, long way from what we're going to be doing here in the class. We're going to be working here in the class and on a small project here in this classroom, and we're going to be wiring things differently. But to get to that point where you guys are actually wiring a kitchen and a bathroom, you guys are going to have to work hard towards that, okay? So if we notice, we have our panels. We have our power sources. And our panels inside of the class are 120 208 volts. So that's the system that we have. It is a single phase system. That's what 10 means, that it's a single phase system. So we're gonna have, we had our main lugs, which in that panel we had 3. And we had one where we had our ground coming in. We had another one where black wire was coming in. We had another one where our white conductor was landing in. And this neutral had a bus bar, and it had a bunch of screws. All of these are connected. And here too. That's the design of those panels. then we had our hot conductor that was coming in here, and we had our other hot conductor that was coming in here. So here, I'm gonna do it color coded. Of course, in our panel, it's not color coded, right? But this one, this panel is like this. So we have one of the sides of the panel, one of the bus bars is connected to one line, and the other bus bar is connected to another line. So here in this panel, I can get 3 readings. If I go, for example, this is my line 1, and this is my line 2. So if I were to measure between line 1 and line 2, I would measure the full voltage of the system, which would be 208 volts. If I measure between line 1 and I measure between the neutral, which is the white wire, I would read 120 volts. If I measure between line 2 and neutral, I would measure 120 volts. And if I measure between line 1 and ground, I will measure 120 volts. Line 2 and ground, I will measure 120 volts. Neutral and ground, I will measure 0 volts.
哎，对，给你拿个那个。
他们那个说是切那个电表箱啊，他切那个，实际上我们就是有220的伏嘛，要切那个。
家里，
我们要切那个。他们还有家里的烘干机啊，用电的，要改用那个。烘干机。对，他就改用220的电的。
You can just observe the projects, but don't start taking them
不
apart.
然第一排就没了。
Okay, so I'm gonna go ahead and turn it on. Let's move a little bit back to make sure that everybody can see. I'm gonna turn on panel 8, okay?
第一排的蹲下。
你说英文的，你让我们3个蹲下不行。来电吧。快点，快点。
Alright, so okay, so this one right here is just a voltmeter. So this multimeter will check continuity between 2 points, and it'll also check voltage. So it'll display lights and it'll tell you if it's 24 volts, 120 volts, 208, 240, 277, 480, and up to 600 volts. So here, just like I was explaining over there in the class, if I wanted to take a measurement between my line 1 and my line 2, that's going to be 208. 208 volts, because that's the full potential of this system. You see that? If I wanted to measure line 1 in neutral, that's 120 volts. If I want to measure line 2 in neutral, that's 120 volts. If I want to measure line 1 in ground, that's 120 volts. Ground in line 2, that's 120 volts. Ground in neutral, 0. Okay? Continuity. So for those who, do you guys want me to do it again? Yes.
Yeah.
All right. Line 1 and line 2, 208 volts.
Very thanks.
Line 1 in neutral, 120 volts. Line 2 in neutral, 120 volts. Line 1 in ground, 120 volts. Ground in line 2, 120 volts. Ground in neutral, 0.
Okay.
That's why I have continuity, because these are 0. Okay, for those who saw it, you can move out, and I'm going to go ahead and
Do it
for
again.
those who didn't see it. So, line and line,
208.
208, right?
Yeah.
Line 1 in neutral,
100.
neutral and line 2,
100.
ground and line 1,
100.
ground and line 2,
100.
ground and neutral,
0.
0, right?
Zero.
And this is our system, right? My drawing is not exactly as the panel, but this is how we are. So here, we would connect all of our grounds on the ground bus bar. So we have screws here on the ground bus bar too. And we would connect all of our grounds, so all of our green wires would come in and connect here. And if we have a neutral, the neutral will connect on our neutral bus bar. On any of the screws, it doesn't matter what screw. And I was explaining to Jose, because he asked me, like, in what order do we do it? If you're in charge of a project, then start on the top and then go down with all of the circuits that are coming in, right? But if you're just adding to a panel, you find a screw that is available and you put in your white wire or your green wire, right? There's not really an order to do it. It's just your technique, how you're gonna go ahead and connect to the panel. And then of course you have your power. You would connect to one of these lugs and put a breaker. Let's say that your breaker is gonna be 15 amps. And then you're gonna bring your power. And this right here would be a 14-2, right?
Yes.
We have our ground, we have our neutral, and we have our power coming into a 15 amp breaker. So this is how we run. This is our power source, and from here we branch out to any load that we want. If we branch out to a switch and to 5 lights, or we branch out to a receptacle, anything like that, we start at the panel. Now the wires that are coming here are usually the wires that are coming in from our utility. So our utility will bring our power source. If our system is 120, 240, then we're gonna have 240. If our system is 120, 208, then the maximum amount of pressure that we have in our system is 208, right? It all depends on the system that we have. Now, most of the homes here in the United States are 240. Now, you don't need to change this in your drawing or anything, but 240 is gonna be the max. So in residential, it's gonna be 120, 240. So it would be line 1 plus line 2 is going to be 240 volts. Line 1 and neutral is going to be 120 volts. That's half of the pressure. Line 2 and neutral, 120 volts. Line 1 and ground, 120 volts. Line 2 and ground, is gonna be 120 volts, and ground and neutral
Zero.
is going to be 0 volts. There should not be any voltage between them, but we should have continuity between them. That's why you guys heard that noise. That was continuity because they're actually connected at the power source. At the power source, they're connected. So this is the most common system that you guys have in your home. You will see that your panel actually says it's 122.40. But you can have 122.08. You can have 480.277. You can have 360. You can have 480. There's a lot of different voltages depending on what you're going to. If you're going to residential, this would be 208 would be small commercial, right? And sometimes you'll have even 3 voltages. You might have 120, 208, and you might have 480, or you might have 480, 120, and 277, right? So you'll have 3 different voltages depending on the type of system that you have. But this is single phase. For other voltages, then you go into 2 phases or 3 phases, okay? But we won't dive into those yet. Yes?
So on the right side of the bottom right side of the panel, that's where the red goes, the 14.3 or 12.3?
On the bottom sides of the panel?
Yeah, where 14.2 is going out.
No. So the panel has openings on the top and it has openings on the bottom. So if you're gonna go with your wires and you're gonna pass them through the attic, then you're probably gonna bring your wires to the top of the panel. But if you're running your wires underneath the house, then you're probably gonna use the bottom part of the panel. So the panel, you can access it even from the sides, depending on the type of panel. So wherever the panel maker allows you to access it, you can put in your wires. There's no reason or there's no rule that tells you that you have to go through the bottom. There's no rule that tells you that you have to go through the top. Only the manufacturer will tell you for certain panels that you can't use the top, and that you can only use this wall, and this wall. But that's the panel manufacturer for any reason. The type of panel will not allow you to do it. But for residential, most of the times our panels are inside of the wall, and we can go through the top, through the bottom, and even through the sides of the panel. Okay? So does anybody have any questions? Yes, Jose?
Like the 14.3, where the red wire is used,
Mm-hmm.
does it go through the right side? That, like while 14.2 is on the left side?
Yeah, you can put it either side.
Here or here?
Yeah.
No. They could go here. They could go in any space. We'll get deeper into how we would use a 14.2, and if we're using it within the system, then we don't really worry about the breaker. But if we're using it from the panel, then now we're sending 2 circuits. So I'll get into that. Don't worry.
Are we gonna be installing like the panels as well when we go to mod?
In mod 2, yes.
Oh,
In mod 2, yes. You guys are gonna be opening. I'm gonna show you guys how to make the holes in the panels, how to measure. You guys are gonna be placing your raceways in, because now in mod 2 we're gonna be doing commercial. So we're gonna be using 2-inch pipe. We're gonna be using a 1/4-inch pipe, 1/2-inch pipe, 3/4. But that's in mod 2. In mod 1, we focus only on Romex, and Romex just use connectors to go into the. Maricela?
Would you be kind to go over again the 14.2, 14.2? I missed it, sorry. What it means, 12 over to 12 over.
Yeah, so the 14.2 is that you have 2 current carrying conductors. So if you guys notice, they kind of ignore the bare wire, right? They don't really count it. So the 2 here is for the black and the white. The 3 here is for the black, the white, and the red. The bare is not counted because the bare is only for safety. Here, the 12.2 is the white and the black, but now here in 12 we have a thicker wire. 12.3 we have a thicker wire, and we have 1, 2, and 3 conductors that can actually carry current.
Thank you so much.
All right, Jason, did you have a question? No, you were just stretching out. Okay. Okay. Don't stretch out, cause I'll call you on it. Alright, if you guys are yawning or you're sleeping, you're gonna make me sleepy. Okay? Alright, so any more questions?
Well, the ground wire, I know it's for safety, and I think the reason it's called ground is because it runs the current into the ground versus someone touching it, but how exactly does it protect you?
Well, this is kind of complicated to explain, but let me put it this way. In a freeway, have you guys seen those auxiliary lanes? Where
For
if
the
you
semis?
if you lost your brakes, it's
Yeah.
not really only for those, right? If you lost your brakes, you can go in through there. So it's an auxiliary path, right? So that you don't crash it into other cars. So our grounding wire is actually like an auxiliary lane. So if current is passing through a path that is not intended, so you want the current to go from that switch to that light. But if for any reason one of the wires get loose in that light and it touches the metal frame, now the metal frame is soldered with that green wire. So that's like an auxiliary path for some of the current to pass through. So you're still gonna get shocked.
Okay.
But in theory, 90% of the current is gonna go through that green wire and trip the breaker in milliseconds, in theory. But you're still gonna get shocked. So, but they don't want all of the current to go through your body, they want most of the current to go through that wire, and that's why it has to be uninterrupted in every part of the circuit. So if you interrupt it anywhere, maybe if somebody didn't connect that green wire over there where all of the greens are, that light is not gonna be protected and all of the current is gonna flow through your body instead. So that is an alternate path for current to travel back to the power source and trip that breaker. That's why it's connected to the panel, and at a certain point, the neutral and the ground are connected so that it can go back to the transformer and it can get really strong and trip. But that happens in seconds, in 2 or 3 seconds it could happen. And how many alternations will happen in 1 second? 60. So 2 seconds is a long time, 3 seconds is a long time. That's why they have other devices that are much more sensitive that will trip in milliseconds, so in a thousandth of a second, right? So this is the purpose of the ground. In Mod 2, we actually spend a whole week talking about grounding and bonding, how important it is to ground. And mostly in commercial, because in residential, we have plastic boxes, right? We don't have metal boxes. But in commercial, we have metal boxes, we have metal frames. Everything is made out of metal. So anything could get energized. So that's why from the foundation, you start with your grounding. From the people that are putting in the foundation, they're grounding every single I-beam. So that when you connect to your panel, you can connect to any of the I-beams and now it's grounded. So it's a big deal. Grounding and bonding is a big deal. The larger the project becomes, the more important grounding becomes as well. So we start in residential to hammer that down to the students, how important it is that if your device doesn't have a green screw, make sure that you connect it, because when I turn on the power, I always hold on the devices to the yoke, right? To the yoke of the device, because I'm pretty sure that there's no current gonna be flowing through there. If current flows through there, I'm still gonna get shocked, but it's just gonna be a bite. I'm not gonna get locked into the current because the rest of it is going through that green wire, in theory. If the system was wired correctly. If you tightened everything and if you didn't interrupt it anyway in the system. So we have to check continuity. When I'm checking their projects, I'm checking continuity to make sure that from the panel to every point of the circuit, the ground is connected and it's not interrupted, because that's very important.
Thank you.
Okay? I would said a bunch of things. Did you understand? Yeah?
For the most part, I think
Yeah.
the basics.
For wires on the diagram, the yellow is for the white,
Yeah.
the green is for
The bare wire?
the wire, and the red?
This red one
Yes.
is the red wire.
Red one, alright.
In the Romex, there's a red wire. Yep. So I wanted you guys to see it because I'm a visual learner. If I see drawings and I they're talking about something, I really have to visualize it. So that's why I like to have setups so that you guys can see how your boxes are put up and how we're running the wires. You notice that we're just creating a path for current, right? Wherever we want it to go, we're running the Romex to a switch, and from the switch, we're going up to a light, and from a light, we might go to another light, and from that light, we might go to another light. So we're just creating a path for current, just like when you're running water in a house. You're coming in from the service, right? You're coming in from the service, and you're going into the first bathroom to the second bathroom. You're going into the kitchen. You're going into the garden hose in the front. You're going into the garden hose in the back. You're going to, and then from there you can tap in to go to the maybe swamp cooler, or you can tap in to go into the sprinklers for the plants, right? You're just creating a path for water. Electricity is almost the same thing. You're creating a path for electricity to flow and to do work for you. Right now, electricity is turning on those lights, and it's doing work for us in the what do you call it? The meter, right? The electrical meter is turning, and it's measuring it's measuring it per hour, how much wattage we're using, so that they can send a bill to the school and tell them, okay, you consumed all of this in a month because you had so many lights, and in commercial, they'll draw it down very detailed. In residential, it's not that big of a deal. We don't consume too much power in residential like we do in commercial. Okay? Any other question? No? Take a break?